This video is sponsored by CCA.io.
So the compiler is not small, so I will just do a quick walkthrough and then feel free to drive the discussion in any direction you want, because I will just go vertical through the various layers quickly. Only one example, unless you want more. So that's the only example I have in mind. X plus 1, and then you apply it. Okay. So I will just use the Okay, so two things happened. The function was compiled, and then magically A becomes 11. So now we'll see step by step how we got to this point. Okay, so this is where we just finished. So you can print the parse tree. The parse tree So there is an item which is the function definition, and then there is the function application and the constant. So, okay, so I've used this internal option, and this is what the root of the compiler understands. So this is the root of the compiler. So that's the main, has all the main compiler flags. There are quite a few with interesting names. Like if it says no test, probably it's for test, and vice versa. But and the other thing is, let's look at what happens with uncarried mode. So even though uncarried is on by default in the configuration, at the root of the compiler it's still not on by default. So let's see what happened. So if we look at the parse tree, this is the function definition, and then there is an arity attribute that gets inserted by the parser. It says the arity is 1. And there is also some internal representation. So the functions are actually internally represented as a variant with an internal name $function. And then inside you get the actual function. And that's it. And then in the case of application, there is an attribute which says unary application. So far we're at this level. So we are in the parse tree. This is the untied parse tree, which comes straight from the parser. So we can look at, I don't know, one of these nodes, like px apply. That's the application, takes function applied to a list of arguments, maybe with some labels. That's the way you would expect. In terms of function definition, that's a little bit more interesting. So it's in here, px fun. So it always takes and only one argument. So when you have a function of several arguments, there is no way to represent it internally. If not a function which returns a function which returns a function. So that becomes quite interesting with uncarried mode, because basically what it does is it wraps this thing inside of this function variant, and then needs to be able to be careful to preserve it and not try to apply currying in various spots. And then play with that until the back end without ruining it, and then give the illusion that internally you have the uncarried. So this is the untyped parse tree. So let's take a look at the typed one. Let's do this. to see what changes. So this is the untyped and followed by the typed ones. So the type is almost identical. The only thing is that, well, foo has a certain identifier, so if you have several variables declared, it knows which one you are referring to, like if you apply shadowing. It has figured out what you mean by plus, so it's defining pervasives. And other than that, not much has happened. So we do the same with uncarried mode. And now things get a bit more interesting. So far not much difference. Here is that the pervasive plus is coming from the uncarried version of pervasives. Right now we have two versions of a few standard libraries, one for carried and one for uncarried. And depending on which mode you're in, it pulls in the relevant one. And then in the case of application, things have become a bit more complicated. So basically there are a few wrappers around to make sure that the application doesn't try to apply conversions that only make sense for carried code. So there is a bunch of stuff in the backend that, for example, in the case of opaque, let's see what this does. So it's a unary application, and then it applies foo. Yeah, I think this opaque just wraps the function foo so that it doesn't get inlined or applying too early in a way that would make sense for carried function, and it doesn't for uncarried. So basically, all the carried stuff is a special mode in the compiler, which is not the default in any sense. So if it becomes the only possible way in future, something has to kind of turn upside down, and only that things are simpler. So yeah. Okay, so we have seen kind of the two layers, the untyped AST and then the typed AST, and then the next level is called lambda. And for consistency, it is called row lambda. I'm not sure why. So this is not much has happened here. The function is just x plus 1, and the application is still there. So even though this is the kind of the last layer before code generation, there is a difference between this code and that code. Like this A is 11, and here A is still foo applied to 10. So that's where the backend takes over and takes this lambda and then applies some transformation and then generates the code in the end. In the case of uncarried, I'm not sure there is, well, let's see how much difference there is. Not, yeah, let's see. Yeah, there are a few wrappers. This is probably to protect the function so that it's not treated as carried, and some opaque here and some application. So in general, with uncarried, things look a little bit more complicated. Yeah. So now the bit I want to show is how the optimization happens. At what point we get from this foo applied to 10 to the result 11. And for that, there is one of the options. Yeah, this one. So this is going to bring a bunch of stuff, and then it's going to generate various steps in the compiler and show you what it has done. So there are a bunch of lam files, which are these lambdas, and the name is the name of the transformation. For example, well, okay. So this was the initial, and A was not optimized yet. It's just full apply to 10. The second step still is not optimized. The third step it isn't, and the fourth step, fifth. So this is when it happens. So on the fourth step we still have foo apply to 10. And on the fourth step is after applying a transformation which is called simplify exits. And then the fifth step says simplify alias. So that's when we expect the inlining to take place.
How much of this is inherited from OCaml and how much is ReScript specific?
So this is mostly inherited from OCaml, but modified. So I think there are a few steps that have been added. Let me check if it's actually true. Okay, so this is the bit in the compiler that performs all these steps. So basically it calls the simplification step, which is this, and then it prints. And then there are, this is the main compile, and then it calls a few transformations. So the one we were looking at is this, and then it was doing some inlining. So let's save this. Is this one? There we go. So we found where the optimization with inlining was happening. So let's see where we are. Okay, that's the main. Simplification function, what is it doing? So if it's a functor does something else. So this is probably where the inline takes place. So this is one of the parts that was actually coming up quite a lot when async functions were introduced, because you cannot inline async functions, otherwise first of all, the semantics is not preserved, and then you also break the generated code, because you put things that are in async context and you print them in a way which is not in an async context anymore, so it's not even syntactically valid. And so there were a few places along the compiler chain where this thing caused a bunch of bugs. And then recently you introduced
we just added directives to functions for like server RC stuff essentially, and we opted to make sure that functions with directives can't be inline, like for predictability. If you have a function that you want to run on the server, then yeah, let it run on the server, even if it would be possible to inline it essentially. So that also came up. So I don't remember exactly. Yeah, we added something to the config for that. Kind of like async, but this was really like much easier than async to get that one going.
So we have seen untied parse tree, tied parse tree, lambda, even though it's not completely true that we haven't even shown what it is. Oh, this isn't. I see.
Why is it called lambda actually?
It's just the name of one of the intermediate languages. I mean, they're all lambdas. So to the question before, if this was part of the compiler, no, it wasn't. So this is these transformations I just checked. They already happen at this level, which is only ReScript, and before BackendScript. So there is a version of Lambda which is a bit closer to generating JavaScript, and so this transformation operate at that level. So let's see if there is anything. Yeah. And so this is the next level, and then, well, I guess the final level is JS dump. Okay. This is what prints. This was generates code. So it starts from something of this form in this J file, and then generates the actual code. So I guess we can
and the J file is like another syntax tree for JavaScript. Or
yeah, J file basically knows about modules. I think there is program. Oh, sorry. Yeah, this is the entry block. There is a list of blocks, some exports. So that's the unit at which it operates, yeah.
So now internally we no longer use this JS of OCaml?
No.
Okay.
No, JS of OCaml is completely different. It kind of tends to generate one big pile of code for your entire project. Like this goes on a file by file level, yeah. That's one
We
of the.
use it for the playground bundle.
Oh, I see.
Well, let's undo the transformation that we did recently. Yeah. Go away. Go away. I think I know what. Okay, so. So anyhow, this was doing kind of the inverse transformation, printing let instead of var. So this is the kind of the various layers: untyped, typed, lambda, and then dumping the code in the end. So that's kind of the vertical cut through the compiler. And there are many, many possible directions one can take it, and if there is anything you want to know or explore, you can do it now or later. Yeah.
Yeah, what would be the ideal representation for a current functions if we have every possibility at our disposal? Will we change the AST and have multiple arguments? Or?
Yeah, I think the ideal representation would be a function definition takes n arguments instead of one, and so everything will be kind of directly representing what you expect it to be. Except that there are these many layers and these many design choices, so this would affect a lot of things. A lot of things. Some of which are understood, some of which are less understood. So, I mean, it becomes like more like a question: are there some small steps that can help simplify things without having to rewrite everything? So that's one of the questions. Yeah.
In the contributing document, there is a small graph that also lists these layers. Maybe it can be helpful. Shall we open it quickly and check if it's still correct?
It's probably in the subfolder.
308.
We don't. This doesn't exist anymore, right? Doesn't matter.
Line 308. Yeah, okay. So this.
Okay. So far, so good. There is a parser. Type.
The pattern matching mechanism is also like modified in ReScript Retreat.
Well, there are many, many things at all levels that are modified. Yeah, I mean, the number of changes is huge. Like if you take the one branch of the Okama compiler now and you put it next here, it's a few functions will be kind of mostly the same with a bunch of stuff added, and then a lot will have moved around and changed. For example, the type checking of application is like twice as much code now, because is it curried, is it uncurried, and then turning around. And then
But generally speaking, we kind of departed now from, because previously we tried to stay as pristine as possible so we can upstream changes. Now we are a little bit more literate about it.
Yes. So the decision was made to kind of not maintain backwards compatibility even for pull requests. So you can kind of make certain decisions and then remove some parts and add some other parts. So the price to pay is that if there is some kind of new feature that is interesting, you want to put it in, then you can't just apply it verbatim. Basically, you need to think about if it fits and if it does, how to integrate it. So freedom at a little bit of cost. Yeah.
If you want to support source maps, I think the biggest issue was that first of all, not all semantics translate one-to-one to, or what I know is like through the optimizations, it's very hard to track back to the original location, or sometimes source exists that actually doesn't exist through code expansion in the compiler. Is this like, is there a quick way how we could potentially support source maps?
I don't know. I mean, this becomes. I was just thinking about the example. So, I need to turn on the optimization again. But if this says var a equals 11, then immediately what's the source map for 11? But also that code that was performing the inlining doesn't have doesn't operate on this kind of information. So all that code will need to kind of operate on some sort of provenance information and then decide how to preserve it and how to manipulate it. Then there is a bunch of code that doesn't really exist in the source, like all these wrappers for uncarried and many other things. Those they don't have any mapping, but they still might generate some code.
Then you also have BPX as the transform stuff that also makes it a little bit more complex.
As well, that also makes things more complex, yes, because PPX can do anything, and so basically it would become a burden for PPX developers to do something meaningful for source information.
When you're talking about the backend, what layers are
The backend is from Lambda, starting from Lambda. Yeah. So let's say that the front end stops at type checking.
Okay. And then all the optimization and
Yeah.
dumping it.
All the rest is transformations, optimization, and code generation.
And for inspecting the AST or the type tree, is there also some graphical utility that you could use, because text form, especially with Anchor, even for small pieces of source code, it gets quite
Yeah.
large. Is there some kind of tweet viewer?
Not at the moment. I guess it will be possible to. Well, okay. So you can use the. How is it called? The tree. Sorry.
AST Explorer.
Yeah. Tree-sitter. You can. I mean, there is a parser which is not identical, but can be used to explore.
Mhm.
Right. So.
Okay.
But it's not the same. I mean, the only thing you could do is to generate some format that then you can explore, but there is nothing at the moment.
So
Other
in
than
your daily work, the compiler, you just use the commands that you just told us to run the various
yeah.
trees.
And the bottleneck doesn't tend to be reading the AST, even that would be nicer to have a nicer form of looking at it. Yeah. Also, sometimes like the difference that you want is just a little annotation which is hidden somewhere, and so kind of the graphical explorer would not help so much with that. Yeah.
Okay. Yeah, not directly related to this, but you mentioned uncurried versus curried, and that curried probably go away at some point. But I think we need to be aware for ReScript 12 if we get core into the compiler, that the current version of core already compiles for uncurried only. So I think it doesn't really make sense to keep curried for too long.
Mhm.
And the same goes for the camera syntax, because it cannot support uncurried mode, as it will not generate uncurried AST. So maybe this is a bit preliminary, because we have a roadmap discussion scheduled for tomorrow anyway, but I just wanted to say this in advance, that I think we have to be aware that we are moving away from supporting current mode, and also from supporting the camera syntax.
Yeah, let's say there are a bunch of directions that in order to enable them, we must remove current mode. And then there are the social implications, like it's a bit harsh, right? So version 11, you don't get curried anymore, but I guess there are enough updates in 11 that there is a buffer. There's not going to be any fundamental reason to jump to 11 for a while. So at least there is a time buffer, even though removing curried entirely is a breaking change. But I think everything is pointing right now that that's the way to go, and I guess it's mostly about discussing consequences of that, but it seems kind of the likely outcome. Yeah. And a bunch of things will simplify for sure, because a bunch of incompatibilities right now are also due to that, like if you use some libraries from JS, then it still counts with carried, just because we didn't want to make 2 copies of everything, of every single library, because it's temporary anyway. So this will be the time to have just one version of everything, and then clean it up in that way.
Yeah, it opens up getting rid of all these distinctions in the compiler that you mentioned, or these hex, or to support both correct and uncorrect with the wafers that you have.
Actually, I have a question. So, in uncurried, you can still call curried functions, which was a bit confusing to me because it's kind of separate modes. How does that work? Yeah.
So I mean that only exists with the idea of migration, right? The idea was that for a while we're going to have this situation in which there is some carried code and uncarried code, and then every little trick was played so that as much as possible things still compile anyway. So if you are in uncarried mode and you have a carried function, then it still calls it. And what doesn't work are callbacks, like the infamous, I don't know, list map. If you inherit a carried one and you try to use it in uncarried mode, you're going to get a type error. So there were a few things that were designed only to support a transition to uncarried mode, and then they are intended to disappear eventually.
But how can you know that a function is not partially applied? Like.
There are two things. One is a function is either carried or uncarried. That's just a characteristic of the function. And then there is a question about what is partially applied or not. And so in terms of partial application, it's supported in uncarried and in carried mode, only that in carried mode is explicit and in uncarried mode is implicit. So removing carried mode means that if you switched kind of the new way, you might have to make some partial applications, either explicit or rewrite them
So
yourself.
if you call in uncarried mode a carried function, it's basically always partially applying that function because it knows it's not uncarried.
Depends. I mean, things don't map so cleanly, like, yeah. I don't remember exactly all the rules on top of my head now, yeah. But, so there is one promotion in one direction which is sound and the other one which is not. And only one of the two you're allowed to do and not the other. So.
Is it possible to have so at work we have like a lot of dependencies on OCaml code. So and then I tried to migrate to like 11. So is it possible to have like all my ReScript code run in uncarried mode, but my OCaml run in carried mode? Is it possible to have that?
How are they combined? Are they in the same project? How?
Yeah, they're in the same project. So basically we have like a lot of Haskell types. Then we have a code generator that we convert the Haskell types to OCaml type, and then we use that OCaml types inside our ReScript. Because we have been using ReScript since the beginning, since like Reason. So I think at that point Reason played very well with OCaml. So and then when this fork happened between Reason and ReScript, we picked ReScript. And then now we have the situation where we have like a bunch of like dependencies written in OCaml, and then I try to like migrate it. It's just like it doesn't work in uncarried mode. So I guess now our solution is either to run everything in carried mode, but that's still going away, maybe in a couple of years. Or we have to just like take the effort to just convert all the OCaml back into like ReScript. But for now, I because we are still stuck on like 10, but I want to migrate to like 11.
Yeah.
So is it possible to have like some dependencies running on the carried mode? Is it possible to have things running on uncarried mode?
So right now there is just per project the setting. If you start mixing carried and uncarried, things become very hairy very quickly. So it kind of more intense. If you rather than it's better kind of once it's time to switch and then have kind of a clean environment. Because also there are a few type errors which are not ideal, to put it nicely. But also it's kind of not much effort goes into that because it's a temporary thing that will disappear. So, that'll be. But let's see, kind of go to the 12. What's likely to happen? So, uncarried is the only thing, or camel is not supported. So, the only two ways are either to generate ReScript types directly, or perhaps generate OCaml types and use an older version of the compiler to convert them to ReScript format. Those are the two kind of possible things longer term, seems like.